Hello, everyone, and welcome to today's webinar, Implementing DevOps at Scale Using Dynamic Test Environments. Before we get started, I would like to go over a few items so you know how to participate in today's event. If you have joined the presentation listening to your computer's speaker system by default, and you would prefer to join over the telephone, just select telephone and the audio pane, and the dial-in information will be displayed. You will have the opportunity to submit text questions to today's presenter by typing those questions into your questions pane of the control panel. You may send your questions in at any time during the presentation, and we will collect these and address them during the Q&A session at the end of today's presentation. Today's webinar is being recorded, and you will receive a follow-up email within 24 to 48 hours with a link to view the recording. I would now like to introduce Pascal Joly, Director of Technology Partnerships at Quali.
Thanks, Kate, and thanks SourceLab for inviting me to speak for this webinar. So I want to start with a short introduction of first the agenda. So we have a busy agenda today, and I would like to, after covering who we are and have a couple of polling questions, I'll go over some of the challenges and pain points around DevOps, and then we'll move on to an approach that helps solve those challenges and implement DevOps at scale in your organization. I'll also cover a case study, and then I'll move on to a live demo, and finally we'll wrap it up with some Q&A at the end. So let's go ahead and get started. So who are we? Quali is a startup company, venture funded, that's offering a product platform, an orchestration platform that's delivering environment as a service that we call cloud sandboxes. So we have about 120 employees spread out in between US, Israel, and Europe, and then over 150 customers, Fortune 100 customers in different verticals, cloud providers, financial services, and technology companies and government. So I would like to throw actually a couple of survey polling questions at this point, and then I'll go over the overall survey itself. So if you want to spend a few seconds filling out those questions. And so each year we actually survey about 2,000 practitioners of DevOps, and we do have a pretty good sampling of the different challenges around DevOps, as well as where people are at in their DevOps journey. So that's always very good for me. I extracted a couple of those questions for you guys to get a feel from the audience today. And I can see that quite a few of you are using continuous integration, which is pretty advanced. And then some of you are still not using DevOps. So we have actually a pretty wide cross-section of the DevOps maturity. Now, let's see about the second question. So this question is really about a core topic that I want to address today in this presentation, and it gives me an idea also about the maturity of some of your automation as of today in your team. And I can see that quite a few of you have, quite a few of you, it takes about a week or so to set up a test environment, and we'll come back to this. So what I'd like to discuss now is review some of the key results of this survey. So we surveyed about 2,000 people in 2016, published a result at the beginning of 2017, and then we did it again last year, and we're going to have actually an upcoming webinar with the results of the 2017 survey in a few weeks. So let me know if you're interested. But regarding this one, and the results are actually pretty consistent between last year and this year. So if you look at some of the key barriers to implementing DevOps, you will see that test automation is number 2, and it's still very much something that's making people uncomfortable or seen as important but very challenging. And then another one, number 4, is application complexity, and looking at all the different new technologies and architecture changes that you have to deal with. Application complexity is actually a big factor in challenging you to implement DevOps. And finally, you have to deal with legacy systems. So legacy was number 3, and this includes brownfield deployment. Always easier to implement greenfield than brownfield when you're talking about new technology, new processes. So let's look at some of the numbers actually that we got out of this survey, and it's always interesting to see the story behind the data that we have. And some of the key highlights of this shows that for 68% of the respondents, the application environment complexity was preventing them from being truly agile and implementing DevOps at speed. And then the other aspect of it is the time it takes to deliver infrastructure. And this is sort of the second leading question I had in the polling today. You'd see that for 33%, it takes actually over a week. 26% of the respondents say it takes over a month for them to get an infrastructure. And some of you will be able to provision your own test environments. Others will depend from a different team, maybe the IT team, and have to wait for capacity or budget to be available for this infrastructure. And then we'll see also that self-service access was not very common across our survey respondents. So if we dive down and for an example of what a dev test environment could look like for instance, a mobile application, we would have your, and you guys might be very familiar with that, you have as a client, your mobile app that could be different operating system, Android, iOS, etc. And then behind the scene, you have a number of backend infrastructure components. You have containers, microservices, data stores. Some of them might be on-prem. Some others might be using different types of public cloud infrastructure, AWS, Azure. And then you'll have also cloud services that you might want to consume, like SaaS application like Salesforce in the backend, and also some potential partner services that you want to implement. So a lot of different moving parts, and everything has to be networked together. The security has to be in place. So this is actually quite cumbersome and complex. And if you have to set it up as a test environment before you release your application in production, this is actually very challenging. And of course, the QA person will say, I can begin to test anything until I have access to everything. So this is something that we'll hear a lot. And the other side of the picture is that we have this paradigm of changing the way testing is done. So if you look at the traditional waterfall workflow where you'd set up an initial project timeline with some procurement to deliver some environments and infrastructure so that you can test your application, we're really changing that with DevOps and agile methods. And essentially, continuous testing is all about shifting left, testing very early in the cycle, and having very short, repetitive test cycles and iteration all along the development cycle until release to production. So this is all about finding bugs early in the process so that you don't have to run into issues when you release to production. And so this is all about automation and velocity. And now the paradigm of DevOps that we really see here is that you have on one end the need for speed, and this is all about delivering and releasing your application fast. But on the other hand, you have the need for quality, which remains and was always there. But in this case, very often we see that quality is being essentially sacrificed for speed. And you don't want risk as well when it comes to having some security issues. So this come into play, and you have to balance those two. And very often what happens is that in order to make the quality happens, then most of the developer and tester will end up using, taking shortcuts essentially. And that means using static environments that you set up once, that are always on. Resources are pre-allocated, reserved. Very often it will be something that works on my machine. So you install it on your own computer, laptop, under your desk, and nobody can touch it. Nobody can really copy it. It's not something that you can repeat easily, and the configuration is fixed. So once you release to production, if something has changed in the middle, you end up being in trouble. So I want to contrast this approach to really shifting the paradigm and using dynamic environments. And we also call this sandboxes. And dynamic environments are all about doing resource allocation, and I've contrasted this to the static approach that I just talked about. Essentially, allocating resources on demand, and not only provisioning the resources that are needed for tests, the virtual machines, the containers, but also reclaiming them automatically. So a sandbox is essentially time-bound, ephemeral. You can actually interact with it when it's up and running, so it has its own state, and you can save it and restore it later. It's something that can be copied. This is repeatable, so it has a configuration that can be augmented or has some parameters that can be dynamic. And then it does require orchestration to at least set it up and tear it down. So that's sort of the main paradigm here. And when we talk about an orchestration, we have this concept of blueprinting, which is really starting to model what your application will look like. And you see here an example of such application using, so here, what are the components of this application? You have some backend database servers. We have some web front end that are distributed in front of a load balancer. We have an app server. And then you also can represent testing components. So in this case, we represented the source lab service that will be essentially testing, running some tests, some Selenium tests against a load balancer. And what the orchestration will do, because you want to attach orchestration to this, is when it comes time to deploy this blueprint, each element will be provisioned, so you can select a specific cloud, maybe a cloud infrastructure or a container orchestrator that you will use in the backend. And then you can read this. The orchestration is also responsible for reading this map and understanding the relationship between the components. So these lines here really represent network segments, but also security segments, and also relationships. So in this case, where you see the service, the source lab service connected to the web load balancer, effectively what will happen is that we will dynamically read the IP address of the flex load balancer and input it into the test that will be run by source lab, so that there is a parameter that will be dynamically read from this map, and that it influences the test target essentially. So another point about this concept of a blueprint is that each application is essentially a little module that can be reused across many different blueprints. So this is something that's very standard. And standard is key to scaling DevOps. I'm going to talk a lot about scaling DevOps. This is one of the main themes of this webinar. And one of the issue that we've seen at many of our customers is that when they use static environment, they have something that's unique to their desktop that's essentially not scalable at all across your entire organization. So you want to take the opposite approach and have modules here that are very standard. And behind the scene, those modules will use the same images. They will have some variations, some input parameters, but they could be reusable across many different blueprints. And each blueprint is each blueprint can be also using dynamic parameters. And so that means if I want to test the latest build number of an application, that shouldn't be something hard-coded in my blueprint. That should be an input parameter of this blueprint. And so here you see an example where I can, at the time of deployment, I'll be able to select a specific build number of my application, as well as I'd be able to set up select a specific data set, because it's not just about the infrastructure, but it's also about the application on top and the data if you have database components. So I want to be able to select a specific data set that reflects what I have in production. So another thing about the dynamic environments is that they enable you, once you have configured these blueprints, to publish them in a catalog, a self-service catalog. And so now you have a set of on-demand environments that can be serving your population of test users, your population of developers, and your population of CI tools. So it's not just users that are going to interact with this catalog, but as well continuous integration pipeline tools through the API. So one important component also about scaling this is that you have the ability to use multi-tenancy. So you should be able, if I'm a user from team A, I will only see the blueprints that are relevant for my team. And then team B will see a different set of blueprints, and attached to those blueprints, you can set different policies. And so, for instance, each blueprint can have a specific time where you're not going to be able to use it beyond a certain time. And then you can also set policies based on usage. So I'm not able to spin up more than 10 VMs, or so you can set up policies at different levels, and that enables you to control your DevOps efforts. So another thing is, once you deploy those blueprints, let's say, for instance, in a specific cloud, then you have the ability, you have now a live context, which means a stateful sandbox. And that means that I'm able to interact if I'm an end user and I want to run, let's say, for instance, here, a Selenium test. I'd be able to actually go directly and interact with this blueprint and run this test from here. So similarly, if something goes wrong with my test that I had run against this sandbox, then now I can go back to the sandbox, the live context of that sandbox, and access, for instance, the console, fix it, take a snapshot, and rerun my test to validate against that new blueprint. So there's also a life cycle that enables you to troubleshoot if something fails and go back to it. So this is some very important concept that is useful when it comes to really implementing this in the real world. So this is sort of just an example of here, I need to access one of the components of this blueprint, and I'm going to directly access it from it. And I'll show an example of that during the demo. So lastly, I have an administrator. So let's change persona for a second. A DevOps lead, for instance, who wants to also be able to have visibility on how these resources are being consumed. And this is all about, so I have all these environments that have been configured, and they represent, for your whole organization, you could have hundreds of environments, essentially, that have been deployed over time. And I want to have visibility of the consumption of those environments and the cost also. And so it's essential for me to see the return on investment of my DevOps efforts. Not only I want to see the test results from this analytics and business intelligence view, but I also want to see the trending. So who has been using which environments over time, and when I say who, it could be a team of users or it could be an API tool, and I want to see the effectiveness of my DevOps implementation and the cost savings that eventually I'm going to realize. So let's now step back for a second, and I've talked a lot about dynamic environments in their own context, but however, they're not a piece that solves everything, and they're actually part of an entire end-to-end DevOps tool chain. And when you look at this little diagram of a typical, what a typical DevOps tool chain could look like, at the very top, you have this CI/CD tool that's essentially a workflow, a higher level workflow tool that does the orchestration of different stages of your pipeline. And it will deploy, trigger a deployment, trigger the test, and for each stage that has been identified until release to production. And underneath that, you have a number of tools that, or many of them are known infrastructure as code type of tools. They could be also CloudFormation templates that are provided by the cloud providers, low-level orchestration platforms that are going to be used in place of the provisioning of these environments. And what's the issue with that is that very often when we look at different DevOps teams, they have their own pet tools, which means one user will have a preference for Chef, another one for Puppet, another one for CloudFormation templates or for OpenStack Heat. And then when it comes to actually organizing these efforts across an organization, it becomes very difficult because nobody can agree on one tool. And the other aspect of it is that it can be also difficult to troubleshoot. So this lack of standards also leads to some error-prone potential issues when it comes to implementing all those different templates. And so gluing it together is something that's easier said than done. Essentially, each one of those infrastructure technologies will have their own taxonomy, very opinionated taxonomy about how things should be done at a given point in time. And so when it comes to really creating a standard out of all this, it becomes very, very challenging. Now, how do dynamic environments really fit in? So when you come back to this DevOps pipeline that I discussed about, and by the way, this DevOps pipeline itself is typically actually triggered from a change in a code. So I'll show it. I'll show an end-to-end demo of what it could look like. And at the top, you have tools like Jenkins or ARI tools. And when you have identified all those stages, now you can map individual blueprints to each stage of the pipeline. And each time you can call a blueprint and deploy it, tear it down with standardized orchestration, and attach also a specific service or testing service or technology given the context of what you're trying to test and validate. So for functional testing, I would have a source lab service. For load testing, I would use a BlazeMeter service. Security, I would use a white hat security service, and so on. But you can use those standard blueprints all across this pipeline, and therefore you have the ability to really scale these efforts. And at the bottom, you still have lower level infrastructure that can be consumed by those blueprints, that is going to be consumed by those blueprints. But these are actually components that you would choose and define ahead of time. So I want to wrap it up now in terms of the approach that I've talked about. And really when it comes to implementing all this in your organization, it takes a number of people and a number of steps. And I just want to quickly review this workflow. And I've touched on some of these earlier on, but it usually starts with an infrastructure or application owner who would start the effort of making an inventory of what are their current assets and where do they want to go with these infrastructure assets, and try to identify the different Scrum teams, the different teams that are going to be consuming those environments. And then there is the effort of modeling those different components into the platform. So we have different components such as application, database, tools, services that we define that are going to be eventually consumed by many different blueprints. And then comes the blueprint designer, who is typically your application architect, but could also be a DevOps engineer. And here, what you want to do is model your application as close as possible to what they would look like in production. And you don't want to take any shortcut. So any components that's likely to change, you'll make them as parameters, dynamic components, and then we'll have the standard workflows that are wrapped around those blueprints that are going to provision and terminate those blueprints, as well as more custom workflows that you can build on top to customize the configuration part, for instance. And then once you have those blueprints, then you have a way to standardize all your environments and you publish them to a self-service catalog, and they become available for the blueprint consumer, which would be either your test user or your developer or an API tool to automatically consume, which means provision on demand and on any types of cloud. And at that point, they become your cloud sandboxes. And those cloud sandboxes offer these users the ability to access from a single pane of glass all the testing capabilities if needed, and access the infrastructure from a console standpoint for troubleshooting, for instance, as well as executing some additional automation against it. So everything within the blueprint, the sandbox can be extracted and consumed by some other testing technology like the source lab services. And finally, we have the infrastructure owner who is going to have visibility on the overall consumption of this infrastructure, the trending over time, and be able to present a return on investment in terms of the DevOps strategy and the effectiveness of the DevOps strategy. So now that I've talked about sort of the theory, let's talk a bit about the practice. So we recently had an engagement with a global manufacturer in Europe who has been going through some digital transformation. And originally, they're really not a software organization, but they realized that software is the only way for them to remain competitive and they wanted to build a global digital presence in the public cloud. So using Microsoft Azure in this case, and they wanted to have both production and dev test environment deployed in the public cloud. And they do have large number of developers and testers, over 100. So they did have a scale challenge from the very beginning to make this happen across several countries. So what were the pain points? Something that I've touched upon earlier on in this presentation. First, they realized that with their current practices of using static environments, they could not scale. And beyond that, so it took for them a very long time to actually get the environments for developers and testers, as well as they had a huge problem of quality, so a really large number of bugs when they were releasing to production. And finally, they had millions of dollars of cloud bills because all these static environments that were defined for developers and testers were always on. And they got really out of control in terms of Azure cost. And so they realized that they really needed to have the ability to enforce standards. So the persona involved, they had a number of teams with developer, tester, team leads, and all they needed was access to a pre-configured environment when I needed. So when I wanted access to this environment. And then they did have a small DevOps team, 2-3 people, and they wanted to improve. So their responsibility was really to provide to these users what they need, and as such, improving their productivity. So as we worked with them to implement dynamic environments, we really went through the step that I described earlier and really started small. So we broke down the implementation in 2 phases. And the first phase was about finding the key main use cases that are most relevant for them, that would show sort of the low-hanging fruits, that would show the best results. And I worked with the Scrum team to implement these. So we provisioned on-demand environments for the developers, then for the testers, for feature validations, and finally for the CI tools so that they can be consumed for the nightly build. So we did remove this dependency on those static environments, and as a result, accomplished both increase in velocity and quality. And then the phase 2 was all about defining the building blocks to integrate with the overall CI tool chain. So we didn't want to displace necessarily the existing CI tools that the customer already has. They had TeamCity, Octopus. So we actually built integration so that TeamCity could be used as a CI tool, and then they could use Octopus for their production release deployment, and essentially integrating everything with building blocks of orchestration to meet the needs of this customer. So now what I'd like to do is run a live demo of what I just talked about using our platform called Cloud Shell. And just to give you a little bit of context, I will wear multiple hats in this demo. The first one will be, I'll be a developer, and I want to make I want to essentially test my new build. So I'm going to make a code change and then push it out to a Git server, and everything should happen magically after that. And then I'm going to have also wear another hat, which is sort of the DevOps engineer who has access to all the tools, so I can show you a little bit what's happening behind the scene. So I'm going to exit now our presentation and go over our platform. So here, let's start being this developer that I just talked about. So here I have my my Visual Studio IDE, and I'm just going to make a small change in the code. So here you go. All right. So here I'm going to save this change. And as I'm saving this change, I'm going to go to my Git client, and I see that I have an uncommitted change. So I'm going to commit that change. And now I'm going to save that. Okay, commit to master. All right. So now I committed, I made that change. I can look at the history of this change. Okay, I just removed, I just added the exclamation mark. I'm going to sync now to the master Git server. And essentially what I'm doing now is this sync to the master Git server will actually trigger a new build in Jenkins. So I have my Jenkins server here that's open, and now I have this pending build. And what I'm doing here is essentially we're actually creating a new build now, build 1.17. And you can see that it's been already created. And another tool that's involved is a build repository. I don't know if you're familiar with Artifactory, a tool from JFrog, but we're actually uploading that build to Artifactory. And then what's going to happen is that here you see that we're actually going to start a new sandbox attach, and that's going to consume that build. So in this case, we're doing really a functional testing of high availability. And in this case, I could have, for instance, the source lab service executing some functional tests here. And we are launching a new sandbox. And so automatically, Jenkins has called the API of Cloud Shell. So I'm going to go to Cloud Shell now. And here I have my catalog of blueprints. And what's happening now is that automatically Jenkins has launched a new sandbox. And this sandbox here, I can see it here. Okay. Okay, so I start a new sandbox, and then what's happening next is that I'm going to run the test against this sandbox. So if I go back to the blueprint catalog here, I can see here the different blueprints that are available for me, and you see here this high availability blueprint that's going to be deployed. And here you can see the different components here that are available to me. And the way you build a blueprint is actually pretty simple. It's just basically you drag and drop from a catalog, and then you can just select the components and add it to your canvas. And the other thing that is available is once the blueprint is deployed, you can access any of the environments here and also have different commands available. By default, you have the setup and teardown, but you can also have snapshots, take a health check, and do a variety of other types of tests. So here, I have here the Jenkins pipeline. And now that we're going over all those stages, the next stage will attach, trigger a blueprint that's actually slightly different because I'm going to use that blueprint for the performance test. So if I go back to my blueprint catalog here, I have a slightly different blueprint here that's used for the performance test. So it has a little bit more added complexity, and it has also, in this case, a JMeter server that's going to be used to run the performance test and validation. So that gives you a little bit of an overview of how this end-to-end blueprints and sandboxes can work together. So now I'm going to go back to the presentation. So I just want to tie it back together. So we talked about dynamic test environments to scale DevOps. And scaling DevOps is really about having the automation end-to-end within the CI, within your CI/CD pipeline. And so that once you have those blueprints available, then they are no longer the bottleneck. And that enables you, once you have a standard process, to really make the speed of releases a reality for your entire organization, not just for one single small user, but really across all the different teams. And then the second aspect is that you don't have to compromise speed against quality. And the fact that now you have production-like environments that are truly representing what you want to have in production, compounded with continuous testing, then you can really have a better predictability of your results once you release to production, and have a much better quality of application release. And finally, one of the additional benefits of using these processes is that you are able to control the cost and your capacity of your infrastructure. So if you're using public cloud, obviously, you'll be able to limit the costs because all those machines that you create are automatically deleted after when they're not in use. And if you have an on-prem service, on-prem infrastructure, you might be also limited in capacity. So you don't want to have those ghost virtual machines or ghost servers that are not in use. When they're not in use, they're removed from your hypervisor, for instance. And you have also the trending so that you can prove the DevOps return on investment. So before we move to Q&A, I just want to prompt you for, if you want to really learn more about this, you can ask us for a technical demo, start free trial. We also have an SDK available for download in our community. We have also a developer community that's pretty active with a lot of open source plugins that are available with the different DevOps technologies and tools. So I invite you to visit it and contact us at info@quali.com if you want more details. So that said, I'm going to open up for Q&A.
Thanks, Pascal. That was great. And we do have some questions rolling in. One is pretty specific from Marco. He says, hello. It is still not clear to me how I can load the application I'm testing to Blueprint.
Okay. Yeah, that's a very good question. So a blueprint itself, and I could I've gone a more extensive demo, but I kind of run out of time. Has when you define a component in a blueprint like a web server, we do have the ability to not only define the image itself, but define also the configuration script that's going to be executed once the image, once the virtual machine is or the container is deployed with that image. And so we do have, for instance, integration with Ansible, but you could also have integration with Puppet, Chef, or other tools, or do scripting. For instance, in this case of the case study that I presented, this company was just using PowerShell scripts to do the post deployment configuration, but it's built in the process of the orchestration, essentially. So the orchestration itself, when we do a setup of a blueprint, when we deploy the blueprint, we have different phases, different stages of this orchestration. And the first one is really provisioning those virtual machine elements. The second one is actually networking, the connectivity. And the third one is configuration. So configuration steps involve, in the case of the example I gave, was retrieving a build from Artifactory and then installing it on the application server. So this is actually really taking care of the application itself on top of the virtual machine.
Good, thank you. We also have a broader question, which would be, how do we calculate ROI for a DevOps program? It's probably a webinar in itself.
Yeah, this is actually a very broad question. I barely touched on it today by showing you different capabilities of doing analytics of the consumption and the training of your infrastructure resources, as well as the test results that you can compound and link to this infrastructure consumption. But yeah, definitely it's a very, very good question, but it's a topic in itself.
Got it.
It will be not a.
And here's one that, well, isn't quite related. Actually, I asked the back half of the question, and that is, it's what are the benefits of DevOps, but more importantly, can one person efficiently handle this job?
Well, it really depends on the size of the organization. I would say if everything is automated, ideally you just have one person who knows about all those automation tools and can supervise everything. But if you consider a really large organization, typically you would have a DevOps lead, and then this DevOps lead might have a number of developers under him who are going to be doing any customization of the orchestration, for instance, of the automation. So we are talking more about, I would say, small team that could be affecting pretty large portion of the organization if you use the right tools, right? And a lot of it is also about culture change. So how much influence that team would have across multiple organizations or business units.
Very good. Onjay asks something a little bit more specific, and this is relating to the demo, but how to promote between dynamic environments, for instance, from dev to stage to production.
Yeah, so typically you'd have some mechanism that you sort of predefine by taking an environment, and then once this environment has been validated, you can actually snapshot it and take a blueprint, essentially create a new blueprint out of it. so that the next time around you have sort of a certified environment that has passed a number of tests and certification, and you're confident that this will be working. But there are different ways, essentially, to slice and dice it. Some companies just like to take it one step at a time and define earlier, ahead of time, your different blueprints, and they will be essentially consistent across the board from the application standpoint. And the thing that will, and once they pass one stage, you'd be able to reuse the same or similar blueprints in the next stage. And then once it comes to releasing to production, you'll be using essentially the same blueprint.
Okay, thank you. I know we've had several folks ask, does this integrate with Microsoft Team Foundation Studio?
Yeah, actually, we did several. We did an integration recently for a customer to integrate with Team Foundation as well as VSTS, so the cloud version of Team Foundation, and we do have those plugins available in our community. So feel free to browse those.
Okay.
Community.quali.com. I forgot to mention.
We'll include that as a link in the email we send out. We also have a question about what happens to the environment after the deployment is done. Is it terminated? What if it is needed to be up for testing purposes?
Yeah, so typically you control when it is terminated. And when I say you control, it's in the case of a CI pipeline, the pipeline tool controls when it is terminated. So the test itself will have an end, it will have a start and an end. When the test is complete, then you can return a completion back to the pipeline workflow tool, like Jenkins pipeline or Bamboo or VS, Team Foundation, for instance, and then this tool will trigger the action of terminating the sandbox. The other thing is, if you need to resume that sandbox at a later point in time, you have the ability to build orchestration and automation to snapshot it before you terminate it, so that when you terminate it, you destroy it, but then you have the ability to restore at a later point in time from a blueprint that looks exactly the same.
Okay. Another, well, not related, but is there a Kanban board within the solution to mark the project milestones and action plan?
No, so we do not have sort of a project integrated, a project function integrated into the platform. And right now, most of our customers, they have already their own solution for that. So.
Okay. Well, I know we're a few minutes early, but that does wrap up the questions that we've received so far. So as we said at the outset, we will be sending an email to everyone who registered, not just the attendees, but everyone on the list, with a link to the recording and to Pascal's slides. And with that, I want to thank Pascal for taking us through the presentation today. And we will see everyone on the internet. Have a good rest of your week.
Thank you.